Hello, this is Dr. McLaughlin with a brief video on how to do graphs in Excel. Couple of things about this. This is not at all meant to circumvent, of course, coming to lecture. What I'm going to talk about in here, everything I'm going to say is going to be stuff I cover in lecture, and in fact in lecture I go into it in a lot greater detail for most of these things. What this video is designed to do is it's designed to help you out if you're doing your homework, trying to remember something I said in class, if you're stuck on one part where you don't remember exactly how to make a graph in Excel, you can't get to the tutors and you can't come talk to me. This video will hopefully help you out, particularly if this is getting towards the end of the semester and you need to do your graphs for the final paper and you don't remember a bunch of weeks ago when you were doing all the SPSS stuff. Might be good to check this out, help you out a little bit. Another warning, this is only really for my section. All sections of experimental require you to do graphs, but other professors might want it in different ways. So might be minor variations. This is specifically for Dr. McLaughlin's class. So what we're going to do, we're going to cover a couple of different kinds of graphs. I'm going to not cover scatter plots because that hopefully by then you kind of remember exactly how to do graphs, and it's not as important as the bar graphs and line graphs that we do multiple times in the class. So that's really what I'm going to be focusing on. We'll talk first about the simplest kind of graph, and that's you've got two means, you've done a t-test, and you're graphing these two means against each other. So here's the example that we're gonna do right now. This is a test of a treatment for anxiety disorder, systematic desensitization. So we've got our anxiety scores. This is after you've run a t-test. Here are the descriptive statistics that you're going to need. We've got our dependent variable is our anxiety score, and in this particular case, a high score is bad. So a high score is indicative of a lot of anxiety, a low score is good. And what you might notice is there is a significant difference between our two scores, and that's what we're going to graph out. We're going to graph out the two means, and as you can see, here's our mean right here. And just by quickly eyeballing it, you can kind of tell that, yeah, it seems like systematic desensitization did work. In other words, the scores are significantly lower in that group than they are in the control group. So we need to know these means. We also need to know the standard deviation. That's going to be important on our graph as well. Occasionally you'll see graphs, or actually very often you'll see graphs that instead of using the standard deviation, they use standard error of the mean. Either of those is fine. It depends very often in the different field that you're looking at, whether you're going to see standard deviation or standard error. But for this video, I'm going to work with only standard deviation. So here's what we need to do. We need to, let me actually move this over here. What we need to do is put in our group names and then our means, and that's what we'll be graphing out. So let's type into Excel what we want our labels to be on this graph. Control, and let's abbreviate this, and then put in our means. You can round off quite a little bit because obviously when Excel graphs it, it can't really tell the difference between 0.3 versus 0.3333. So we round off a little bit. And then another thing that we're going to have to do is put in these standard deviations as well, because we're going to need them for our error bars, 11.66 and 11.24. Now, one thing to take note of is that you have to keep these standard deviations right next to the means that they're associated with. So for my systematic desensitization group, this is my mean, 46, for that particular group, and here's the standard deviation that's associated with that group. It's got to line up like that or the error bars won't work. Okay, now let's make the graph. What we need to do is highlight the group names and the means. For right now, leave out the standard deviations. You're highlighting the names and the means. That's what we're going to build our graph based upon. How do we do a graph? Let's do a bar graph first. Go to Insert, Column. Click the very first kind of column you have, the simplest kind of column graph, and here we are. So one thing to do right now is check and make sure we've done the right thing. What do I mean by that? We've got this control label down here, and it's associated with a bar that goes up to, well, about 73, which is exactly the mean that we intended to graph. We've got our systematic desensitization group, and it's got a bar that goes up to about 46. And that's about right. So that's the first thing to do is look at the numbers, look at the graph. Does the graph sort of match what the numbers are supposed to be like? If the numbers are just way off, then maybe you should try again. I should bring up right here a very common problem that people have, and that's that Excel is always going to graph out exactly what you tell it to. What do I mean by that? Let's say, for instance, when I was highlighting these, I also highlighted this blank space right here. So I throw in this extra blank space, and then I do my graph. Well, guess what? It just graphed that blank space. So it gave you 3 groups, and this third group here is that blank space you just graphed. And it's in there, and then people would go and try and resize this graph and try and do what they can to get rid of that blank space. But Excel thinks you want that in there. So that's one common problem I see. Okay, now that we've got our graph, let's do a couple of things. And this is, always going to be the case. You don't need this legend right here. We need it later on when we're graphing out interactions. But right now, this is completely meaningless. So get rid of that. Click on these bars, these horizontal lines, delete them. That's just a stylistic thing for this class. Some other classes and applications might not tell you to do that. But it's really best if with this graph you've got this nice blank space behind it, and it really sets off these blue bars very well. Now let's talk about our error bars. This gets complicated. Why do I require you to put error bars in? Is it because I hate you? Well, yeah, but there are other reasons. By and large, the reason that you need error bars in here is the same reason that we don't just say, there was a difference between 2 means. One group got an 89 and the other group got a 65. Outside of the context of a standard deviation or some type of measure of dispersion like that, those numbers don't mean anything. For instance, if I were to tell you that for $1,000 you could do 2 points better on a test, is that a lot? Let's say you had enough money to spend and you're evaluating that. Well, if that test is the SAT, probably not, because you know that 2 points out of 2,400 on the SAT, anybody can get that. If the test we're talking about is an AP exam, where the range is from 1 to 5, 2 points is huge. So you really need context in all these numbers, otherwise they don't mean anything by themselves. Let me actually show you an example of that, of the difference between, of why we have error bars. Let's say we did some type of test preparation experiment. I've got a control group and a treatment group, and I've got some type of test here, and I'm just kind of showing you test scores just on average, and what I've graphed out here is that my control group has an average of 35, and my treatment group has an average of 39. But does that mean that my treatment worked? Well, just by looking at this graph, it would seem to imply, yeah, it did. Look how much higher the second bar is relative to the first one. But if you really have the discerning eye, you'll note, well, it's really only a 4-point difference. And if I don't know this test too well, I shouldn't really be convinced that that's much of a big deal. In fact, what we've done with this kind of graph is, this is what's called a truncated graph. In other words, it doesn't go down to 0. It goes down to 33. Now, sometimes people do this just by accident, not realizing that Excel is really just going to try and make the graph look really shiny and impressive. In other words, it's going to select a scale where it makes it look like you have a huge difference. But very often you don't, and very often in the past these truncated graphs have been used to make non-significant results look significant by making it look like this is a huge difference between 35 and 39. Maybe it is, maybe it isn't. So let's look at some of the differences. What happens if these are my standard deviation values right here, 0.6 and 0.7? Let's add that to the graph. I'll go over in a moment how exactly I do this, but you can kind of follow along a little bit. With these error bars added, I can look at this and say, well, actually, it seems like this is an effective treatment. It might not be a big difference, that 4-point spread, but I'm convinced it's a real difference. Why? It's not just saying that the difference went up by 4 points about, it's saying that the people in the control group, well, they tended to bunch up right around here. The people in the treatment group were all bunched up right around here. So in other words, just about the highest score in the control group, right about there, is still well below the entire treatment group. So that tells me that, okay, maybe this is an effective treatment. On the other hand, what happened if our error bars were based off of these standard deviations? Let's see how that changes things. Well, look what happened. When we changed the error bars, Excel actually had to go in and sort of resize the entire y-axis, and with good reason. So before we had numbers that went from 33 down here, down at the bottom, up to 40 on the top. Now, because we've added in these error bars, that provided that extra context that kind of said, well, actually, these two groups are very similar to one another. And look at the spread in scores that we have now. The control group on the left is actually very similar to the treatment group on the right. There are many individuals in the control group within those error bars that would look completely like individuals in the treatment group and vice versa. So now these two groups don't look that different from one another at all. That's why we really should have graphs with error bars on them. It provides that context. It's pretty much the same reason we don't just say, well, Group 1 had this mean, Group 2 had that mean. We run a t-test, and really all a t-test is taking that mean difference and expressing it in the units of the standard error. So that's pretty much doing the same thing. It's looking at a difference between two means in relation to what's the standard error or the standard deviation of those two groups. So that's why error bars become really important. And that's also why anytime you look at a graph, you should really try and look at it for things like a truncated graph. Try and see, does it have some type of measure of dispersion on it, like a standard error, or standard deviation, something that gives you some indication of how far do the groups spread out, and is there a lot of overlap between those two groups. That's what error bars give us. Now to do that, like I said, so this is going back to our anxiety experiment that we just graphed out. Again, here were the means that we've already graphed. Here are the standard deviation values that we're about to add on for the error bars. So click on the graph. If you don't see a lot of these tools of how to fix the graph up, the best thing to do is click on it. A lot of these go away if I click away from the graph. Click on the graph, click on Layout. Over on the right-hand side, Error Bars. Now this gets really tricky because if you just say error bars with standard deviation, it's actually going to give you something goofy that I won't get into. So don't do this. You need to go to More Error Bar Options. You need to go down here to Custom. When you go to Custom, this box is going to light up saying Specify Value. What do you want those standard deviation values to be? And then you've got two of these. Important thing to remember. What goes into this box on the top is exactly the same as what has to go into this box on the bottom. So now that I've got that highlighted for my positive error value, I'm going to go to this graph and I'm going to click and drag these two values right here. And now that's my positive. So in other words, that's the error bar that's pointing up is going to be based off of those two numbers. I need to do the exact same thing down here at the bottom. Same set of numbers. One thing you noticed is this right here, which is it's got this number 1 sitting in there. I tried to get rid of it, but it kept it anyway. Since that happened, it's going to tell me I've got an error. If you get that, there's a very good chance that you've got some random gunk just kind of in here, like this number 1 that I want to get rid of. And how do I know I've done it? The value that I have on the top, what it says right here on top, is exactly the same as what it says down here on the bottom. Now that I've done that, I can click close, and there are my error bars. And again, a person, someone who's trained, can do a very quick, almost significance test just by looking at one group and seeing, okay, the bottom error bar of this group here, is it very far off of the top of this group, this group here? If those two groups don't overlap much, probably that's a significant difference. That's kind of a very quick eyeballing significance test, and of course you should always do a real significance test. But that's something that you can do on any graph that has error bars, just to kind of give yourself a sense of, is this a real significant difference or not? So that's how we add on error bars. Now our graph is looking pretty good, but there's still a few more things that we need to do before it's complete. Graphs should always, including not just ones you make, but ones that you see and read, graphs should always have axis labels. In addition to the scale right here, so Excel is going to automatically put the numbers in, and it's going to try and take its best guess as to what it thinks this y-axis scale should be. But you also need a label. You need something that says, what are these numbers? 0 to 90 of what? The most typical thing you're going to do, remember that a y-axis is always going to have your dependent variable on it. One thing that you can do is go back to your SPSS output. What did you call that measure? What did you call that dependent variable? Here we called it anxiety score. The dimension of our independent variable we referred to as anxiety treatment. So let's keep those terms in mind. Go up here to axis titles. Again, this is under layout, chart tools, layout. Again, if you click away from the graph, those are going to disappear. Click on the graph, they come back, layout, axis titles, vertical axis, rotated titles. So this is the one where the lines, where basically it's written kind of straight up and down. So you put in, among other things, again, these axis labels have to be fairly specific. You want to definitely tell your reader what exactly it means. So something like score would not be specific enough. Anxiety score is a little bit more specific without being too wordy, so you can put that in. You'll also notice that I had to just resize it a tiny little bit. I did that kind of automatically because otherwise when it came out like that, it was a little too scrunched up. You always want to put a little bit of space so you can actually read these things. You definitely don't want text and lines overlapping one another. Now that I've done my dependent variable y-axis label, I'm going to add in the dimension of my independent variable. So here are my groups, control versus systematic desensitization. And I'm going to add in the dimension of that independent variable. What exactly is it? So here we simply enough just called it anxiety treatment. And I'm going to do the same thing. It's a little too scrunched up, so I'm going to do that, give it some more space. You can even just resize the entire graph a little bit. So basically, you know, it looks right. It's sort of boxy as a lot of these bar graphs should be. So that's how we do that kind of graph. We've got two groups. We're doing a bar graph between the two. Those are all the things that it needs to have. It needs to have x-axis and y-axis labels, and also on the x-axis you need those group titles. You need error bars. Now what we're going to do is, let's look at a situation where instead of doing a t-test, so in other words we're comparing two groups, let's say we had 3 groups in this particular study. So a version of this where we're comparing not just systematic desensitization to a control group, but we're actually throwing in another group that's getting a drug treatment, alprazolam, which is Xanax, another anxiety treatment. Well, we're using the exact same number, so here, and this is, as you might be able to tell, this is a one-way analysis of variance in ANOVA. We've got our same means for the two groups, because I just borrowed the same numbers, that 73 and that 46 we just graphed. But we also added in this Xanax group, alprazolam, and it's got its own mean and standard deviation. So what do we do with that? 34.3 and 13.46. Well, we can just add that on. Let's delete this graph for right now. We've just added another group name, another mean, and another standard deviation. we're going to do the graph the exact same way. Click on Insert. Let's do a line graph this time. It's basically the same thing as doing a column graph. It's just going to look a little different, of course. But the first thing to do, highlight all the group names and the means and nothing else. Click on Line, and there we go. There's our lines. Like I said, you want to get rid of some of this junk. You want to get rid of this. Another thing that you can do here is you can add in, it's probably very often a good idea to add in a marker. So you can make these changes. All I did was double click on this line, and that took me to a bunch of options where I can change what that marker is. I added that little square exactly where the means are. I can change the thickness and the color of the line. So those are things that you can do just by double clicking on the line. But what I'm going to do now is I'm going to add in those error bars. Again, that's under Layout, Error Bars. Again, I'm skipping all of these options that it gives me that look nice and simple, and I'm going down here to more error bar options. I'm going to go to Custom, and it's going to ask me what values do you want. Here, I'm going to highlight these values here, these standard deviations for the top and also for the bottom. Again, it gave me this thing right here. It's adding in this 1. I'm going to get rid of that. So again, if I hit OK right now, it's just going to throw an error message back at me that really confuses a lot of people if you're having a tough time hanging on. Very often, you've just got this extra junk that Excel threw in the error bar values. And now we've got our markers with our error bars. I'm going to forgo the axis titles for right now and just talk about the error bars because I know they give people a lot of grief. How can you tell you've done your error bars correctly? For one thing, the error bars should not be exactly the same as one another. In other words, what you have for group 1 should be slightly different from what you have from group 2 versus group 3. In this particular case, again, keep in mind the numbers that I'm basing this off of, 11.6, 11.2, those are pretty similar to one another. But this 13, if I'm looking at this, I'm saying, okay, so the error bars on my alprazolam group should be larger a little bit than my other two groups. And that's exactly what we've got. The error bars reach out a little bit farther here than they do on either of these other two. So that kind of tells me, okay, I've probably done that correctly. Here's another thing. The error bars have to be symmetrical. Let me make this a little bit bigger. In other words, they have to be exactly the same above the dot as below the dot. The same distance. The distance between here and here must be the same as between here and here at the top. So the error bars should be different from one another, but they should be symmetrical above versus below that line. You can make a mistake if, for instance, you tell it that the error bars, let's say you made some mistake and down here this ended up being a 1. So here's where you tell it what the positive value has to be, what the negative value has to be, and they should be, again, exactly the same. So you're going to get symmetrical error bars if what goes into this field is exactly the same as what's in this field. Otherwise, it's going to give you, no, it's actually not even letting me do that. It's going to give you something wrong. You're going to end up with, I've seen error bars where, it only peaks a little bit below. So in other words, the error bar ends right here. So one of the error bars is very long, one of them is very tiny. That's not okay. Now here's the one you've all been waiting for. What do we do with a two-way ANOVA? How do we do all those different graphs, and what is it we're exactly supposed to graph? So in this example, and this is something that's commonly being researched, is what's the effect of multiple drugs in combination with one another? Research being focused on the fact that sometimes people will take multiple drugs at the same time. And this type of study is perfect for a 2x2 factorial design because you're looking at the effect of not just the different drugs. In this case, we're pairing oxycodone, common drug of abuse, with alcohol, the most common drug of abuse. And we're looking at not just do these drugs have an effect, but what's the effect of putting them together? In other words, do alcohol and oxycodone interact in their effects? In this case, it's on a working memory study. So here's what we've got. Here's the groups that we've put together. We have Some individuals who have been given alcohol, some others who have been given placebo drinks. Similarly, some of those same individuals have been given oxycodone, but some have been given a placebo pill. So again, that creates 4 groups. Some people got the 2 types of placebo together. Some other people might have gotten the placebo alcohol condition, so in other words, the drinks that really didn't have any alcohol in them, but they did get an oxycodone pill. Some people would have gotten the other way around. They would have gotten the placebo oxycodone pill, in other words, an inactive pill that they've been told is OxyContin, but they've been given alcohol. And some people, some lucky individuals, got both drugs together. So this is the 2x2 design. So everybody is in 2 groups, in 2 different groups simultaneously. They're in an alcohol group and they're in an oxycodone group. And here, of course, are the means. We've got our marginal means. We've got those individuals, everybody who received the placebo pill, everybody who received the oxycodone pill. Now that's one of our main effects. So that's total. How can we tell the difference between marginal means and cellular means? Again, one important way is that the cellular means are always going to be associated with smaller groups. So those are n's of 6. In other words, there's 6 individuals out of this entire group of 24. So there's 24 people entirely in the study. And that 24 is split up 4 ways. 6 of those individuals got, for instance, alcohol and also the placebo pill. So their mean is going to be a cellular mean. Here's the total for everyone who got the placebo pill. All 12 of those individuals. So that's what we're going to graph out. We're going to graph the main effect of the oxycodone treatment based off of these numbers. Okay. Adding in those means, adding in the standard deviations for the error bars. Creating a line graph. Putting in the error bars. And again, I know I've done it correctly because those error bars are different from one another, but they are symmetrical. They're the same on the top compared with the bottom. So I just graphed out one of the main effects. And again, I would normally get rid of the legend, get rid of the lines, and add the dimension of the IV down here. And I would add, actually let's do that. Let's put in the axis title over here. In this case, it was accuracy on a working memory test. So we can see that those who got the placebo were about 80% accurate, and having oxycodone on board dropped their performance by about 10 points almost. So that's what that says. Now let's do the same thing for the second main effect. Where do we get this main effect from? We're looking for everybody, regardless of OxyContin condition, regardless of whether they got oxycodone or not, everybody who got placebo drinks. Where's their total? Their total is right down here. Everybody who received alcohol, their total is right down here. So those are the numbers that we're going to be looking at. Everyone in the placebo drinks condition, their mean was 85.75. I'm getting that here. Everybody in the alcohol condition, their mean was 64.75. I'm going to add on the appropriate standard deviations. And now let's make this graph. So here are our two main effects. And what they tell us is basically what we can read, what we can see just by looking right at the main effects for alcohol, the main effects for oxycodone. They are significant. In other words, having the presence of either drug, either oxycodone or alcohol, does impair people's scores on this test. Now, how do we do the interaction? Here's an important thing to take note of. Don't graph out the same means you've already graphed. So far, we have graphed this mean, this one, and this one. Read across those lines. Those are the means we've already taken care of. The ones that we have to do now are the cellular means, the unique combinations of the different groups. Those who got placebo drinks and placebo pill, this mean. Those who got the placebo drinks and the oxycodone, this mean. Those who got alcohol and the placebo pill, this group. Those who got alcohol and oxycodone, this group. Those are the means you are going to be graphing now. And you are going to create in Excel a little grid. Let's put it down here. It really doesn't matter where it goes. With the group titles. So here, going down, I've got the two alcohol groups, placebo drinks versus alcohol. Going across the top, I've got the oxycodone groups. Now I'm going to put the means in, but I got to be really careful to put the correct ones. Placebo drinks plus placebo pills. 6 individuals just got the 2 kinds of placebos. And those 6 individuals we can find here. Placebo drinks plus placebo pills, that mean was 85.5. Placebo drinks from the alcohol group plus oxycodone, that mean was 86. What about individuals in the alcohol group? Some of the individuals out of those 12 who were in the alcohol group, half of them, 6 of them, received the placebo pill, and their mean was 73.8. Some individuals received both drugs, alcohol plus oxycodone, their mean is 55. Now I'm going to put in the standard deviation values. Same concept, you really have to put it in the right order. So in other words, I'm going to create a grid right here of standard deviations, but it's going to really be based off of where I put my means in. So in other words, this box right up here, that's going to be the standard deviation of this mean. This box right here will be the standard deviation of this mean, and so on. I'm going to make my line graph. Now that I've got all the information, I can hide the SPSS output. I'm going to highlight these 9 cells right here, all of my group names and all of my means. I'm going to ask for that line graph, and here's what it gives me. This group going across the top, it's put down here on the x-axis. this group, this independent variable, this factor going from top to bottom here, the alcohol condition. It's placed both of my placebo drinks means on the blue line, both of my alcohol means are on the red line. One thing to take note of, I'm still going to get rid of these lines, but in this particular case, I'm not getting rid of this legend. This legend now provides me information that these legends up here really don't. This just says series 1. This just tells you there's a line. Not that interesting. You can get rid of that. Here, you could still kind of click on the field right here and kind of recover this space by moving this over and try and, you know, really resize things and work with things so that things are spaced out fairly evenly, kind of like that. But you can't just get rid of this. Now this is meaningful. This is telling me what these two lines represent. And now I'm going to add in my error bars. It's a little bit trickier even than the normal error bars have been. But you go through the same motions, there's just one extra step. More error bar options. You got to do it twice. You got to say, all right, well, I've got my blue line, so I'm going to add in error bars for my blue line. You do the same thing, custom, and I highlight the placebo drink standard deviations like that. I do the same thing here down at the bottom. It's the exact same set of numbers, and it gives me those values. Now, I'm pretty much going to do the same thing. I'm just going to do it a second time. Okay, I can tell I've done it right because I'm looking at my standard deviation values and it's telling me, all right, most of these numbers are 5. So 3 of these error bars should be about as large as one another. It's this one right here, the combination of oxycodone and alcohol. Not only does it provide the lowest mean, but it provides the largest standard deviation. And so the error bars are going to be the biggest, and that makes sense. You've got 2 drugs on board. Different people's performance might be very variable from one another. So that might happen. So now we've got this interaction, and it basically says that we look at the graphs of our main effects up here, and they tell us, this one tells us having oxycodone produces a working memory impairment compared to placebo. This one tells us having alcohol produces a working memory impairment versus placebo. What the interaction is telling us is that not only that, but the combination, this dot right here, the combination of alcohol and oxycodone together produces more of an impairment than either one alone. That's what the interaction is telling us. In the interest of time, I'm going to skip a couple of the things again that I should have done, putting a y-axis label on here. I will say that just as a reminder, I will bring this up in class, but the y-axis scale, here it goes from 0 to 100, that seems to be pretty good. The y-axis scale should be the same for all 3 graphs. In all 3 cases, you're graphing out accuracy. So it should be exactly the same. And again, one of the things you notice, and this is always going to be the case regardless of what kind of study we end up doing in class, graph 3, the one that has these cellular means, it really is going to cover the largest area. In other words, it's going up from here, the highest error bar line here, that little dash is well into the 90th percent, it was well into 90%. The lowest part of this error bar here is down under 50%, under even 40%. So make sure that you do this graph and then you go back and make sure that the other graphs have the same scale as this one on the y-axis. How do we do that? You just double click it. Once you double click it, you can mess with these options like what's the highest and lowest value here. So I can change that if I wanted to. So normally the default is automatic, Excel picks it for you, but if you want you can go in and change it so now it's 30%, so that's as far down as you're going to go. So we've just changed it, we've changed the scale a little bit, it only goes down to 30%. So those are some things that you can do. But make sure that whatever you do to this graph, you do it to these other graphs because really they're supposed to be graphing the same thing. So that's something to keep in mind. Excel does not necessarily know that these 3 graphs are related, so it's not necessarily going to give you the exact same scale like it did here. Okay, other than that, these graphs look pretty good. They would all need the dimension of the independent variable. And that's about it. Other than that, these are good to go. If you got any questions, please come talk to me. Thanks very much, and good luck.